Okay, welcome to lesson 23. We're getting started momentarily. Just make sure we have Florida Math Live up. So if we have any questions, we can get those taken care of. And if you do have any questions about this lesson or any material you are covering this summer, feel free to post those in the comments and I can help you with any problems you are perhaps stuck on. And we'll get the behind the scenes camera going in just a moment here as well. We'll wait for one more minute for everyone to jump on and we'll get started shortly. Okay, hello, welcome to lesson 23 of the summer live streams to get everyone ready for their algebra and geometry classes this fall. We are going over exploring angles of triangles today. Yesterday we talked about parallel lines and transversals and how some of those different relationships, how you can find supplementary angles, how you can find congruent angles, and those sorts of things. Okay, so let's get going. So the drawing shows that if you place the three interior angles of a triangle adjacent to each other, they will form a straight line. So the sum of adjacent angles is equal to 180 degrees. So the sum of the interior angles of a triangle is 180 degrees. And if you, what they actually did here is if you were to take this triangle and rip the corners off, is what they did. If you were to take that triangle, rip the corners off, and put all the points together, you would have a straight line, and that's what they're illustrating here. As you can see, the 68 degrees, the 67 degrees, and the 45 degrees, those three angles from the interior angles of the triangle form the straight line, showing us that the angles of a triangle add up to 180 degrees. So let's look at the first example here. ST is a right triangle, and we want to find R. So how we would do that is if we know that 36 plus S, this symbol here shows that it's a right angle, which means it's 90 degrees, plus R. If we were to add up all of those angles, we're going to have 180 degrees. So now it's just a matter of solving for R. So if we put these two like terms together, we should have 126 plus R equals 180. Subtract 126 from both sides. That would cancel that, so we're left with R equals 54. Okay, let's see if they did a different approach. Pretty much the same process. So really what you're doing is you're seeing what that missing piece was. So we knew two of the angles, and we're always going to need to know two of the angles to find the third angle, because we can't really have more than one unknown. Let's have a look at this example. So it's saying M and an EF are parallel. So explain how we can tell that triangle DMN and DEF are they're similar. Let's go back up and review what similar is, and that's going to help us in this example. So recall that similar triangles are two triangles that have the same shape but may not have the same size. So in similar triangles, the corresponding angles are congruent, right? So these are both 40. The top angle is 110, and the right angle over here is 30. But the measures are different, right? So this side is 2, this side is 3, this side is 4, the corresponding side is 6. So the sides are different sizes. The angles are the same, the sides are different sizes. So we're talking about similar triangles here. But when we look at the ratios of the lengths of the corresponding sides, they will be equal. So what that means is if we put one over the other, 2 over 3 is going to be the same ratio as 4 over 6, right? So if you put that in the calculator, 2 over 3 would be 0.6 repeating. 4 over 6 is also 0.6 repeating. 5 over 7.5 would give you the same thing. So down here, it's showing that. So the corresponding angles of A and R, those are corresponding angles. They're both 110 degrees. Angles B and angle S are corresponding angles. They're both a measure of 40 degrees. Angle C and angle T both have a measure of 30 degrees. And when we look at the ratio of the sides, so AB over RS, so this side over here, 2 over 3. This side over here, 4 over 6. If we reduce that, we would have, again, 2 over 3. 5 over 7.5. We could reduce that also to 2/3. Okay, so that brings us to the angle similarity theorem, stating that when two pairs of corresponding angles of two triangles are congruent, the triangles are similar. If two pairs of corresponding angles are congruent, then the third pair of corresponding angles must also be congruent. So it's essentially stating that if we wanted to prove that these two triangles were similar triangles, and we did not know what this one over here was, we didn't know that it was 30, we wouldn't need it to prove that we were dealing with similar triangles, because the corresponding side of angle over here is 40, and the corresponding angle on top is 110. And we would have 2, and that's enough. So 2 of the 3 that we know are those angles, those measures, then we would be able to say that it is indeed a similar triangle. Okay, let us know if you have any questions. You can put it in the comments. Remember to visit FloridaMathLive.com. The new interface we have makes it a little bit easier and cleaner to communicate the topics and lessons that we are covering. So let's go back to example 2. So in the figure below, MN is parallel to EF, and explain how you can tell that triangle DMN is similar to triangle DEF. How can we say that they are similar? Well, so essentially what we're looking at, if we were to draw, one way we can do this to visualize this is I'll make the little triangle, DMN triangle, kind of outline that in green. And remember that theorem that we just learned, that if we can find 2 angles that are congruent, then we know that are the same measure, 2 corresponding angles that are the same measure, then we know that the 2 triangles would indeed be similar, and that's the symbol to show that these 2 triangles are similar. So what if we did it as a green triangle and an orange triangle? How about that? And can we show that these 2 triangles are similar? Okay, so D is this left point of both triangles, really. It's a common angle. So what that means is this angle D for the green triangle is the same angle D for the orange triangle. So you could almost write it like this and say the green angle D is the same measure as the orange angle D. Now we just need to find at least one more set of corresponding angles that are the same measure. So remember, I'm adding these extensions to hopefully jog your memory of what we covered yesterday about parallel lines and transversals. And it did say here that MN and EF are parallel. Okay. And that would make this line DE, and if we're going to extend that one as well, that would be like the transversal, right? And there's a rule about corresponding angles of a transversal passing through a set of parallel lines that would state that by corresponding angles, this angle, so angle DMN, would be the same as angle DEF. Okay. So we can't just write angle M in this case, because angle M could also be referring to this angle over here. So to specify, we didn't have to specify 3 points here because there's only one way we could interpret. There's no way to misinterpret what angle D is. But here I might write D, M, N to kind of give directions of the lines that are forming this angle. So angle D, M, N is equal to angle D, E, F by corresponding angles. And now that we have 1 and 2 angles that are congruent, 2 corresponding angles are congruent. So by the angle-angle similarity theorem, we would say that DMN is indeed similar to triangle DEF. All right. So here's a little bit more information, more definitions. It's talking about when the sides of a triangle are extended, 3 new angles are formed. These angles are called exterior angles of a triangle. So does everyone see that? If I were to cover these up, that's our original triangle. And if we were to extend these lines straight out, then it's going to make a new angle. Okay, so if we extended PR out this way, it's going to make this new angle of 120 degrees. If we extended RQ out, we would make a new angle of 130 degrees. So the exterior angles and its adjacent interior angles form a 180-degree angle. It's a straight line, right? So this angle here that's formed, if you combine the 60 degrees with the 120 degrees, you have 180 degrees, or a straight line. And remember that 2 angles that add up to 180 degrees are called, when a pair of angles forms a straight line, they're supplementary angles. So the sum of the measures of supplementary angles is 180. Similarly, we have one more definition. So if it adds up to, maybe I'll even underline these, so supplementary add up to 180 degrees. Complementary angles add up to 90 degrees. Okay. A few more definitions. I'm sure that will help us in the coming examples. Let's see what we have here. Okay, so let's use the supplementary angles, interior angles, and the exterior angle of the triangle to write an equation, then solve. So to find the measure of angle MLN. Okay, so that's the strategy we just learned about the supplementary and complementary angles. All right, so we just learned this. So if we started originally with this triangle here and we extended NL past here to form this line, we have a straight line, and when we have a straight line, we have 180 degrees, which means that these 2 angles, angle MLW of 105 and angle MLN of X, will combine. They're supplementary. They will add up to 180. So all we need to do is do 180 minus 105, and that will give us X. That would be, what, 75? And that's how we would find X. All right, let's try one more. So this one is a little bit further away. Can we find angle BAE? So this outside, so we want that angle. That's our X angle that we're looking for. How do we get there, though? Well, it would be helpful if we knew this one, because then we could use the straight line strategy that we just practiced, that we could do 180 minus whatever this angle is to get this. But we don't know what that one is yet. But what did we learn earlier about angles of a triangle? The 3 angles will add up to 180 as well. So I'm going to label this one maybe angle y. Why not? We can call it y. So we would actually write, move it over to the side a little bit. So 180 equals y plus 46 plus 49. So how could we find y? So let's show the work in the calculator for this one. So we have 46 plus 49 adds up to 95. And then that 95, so these two add up to 95, and we're going to subtract those from both sides. 180 minus the 95. Oops. Gives us 85. So that would be not the answer we're looking for, but 85 equals y. So how would we find x? So x, or rather 180, equals x plus y. We just figured out y to be 85, so 180 equals x plus 85. Subtract 85 from both sides. We should have 95 for x. Okay, let's see if we can try a few more examples. Let me know if you have any questions about the material we're covering, or if you have some other questions from summer school or another class that you're taking, I can go over those as well. All right, so a triangle has the measures in the ratio of 1, 2, 3. What is the measure of each angle of the triangle? Okay, I'll give you a minute to think on this one. So one way you can proceed with this type of problem is we know that if they are in a ratio of 1 and 2 and 3, but we don't know what the actual angles are, right? So we can use x. So 1x plus 2x plus 3x equals 180. Okay. Actually, right away, we could also start to cancel some of these. Anytime you have angles that add up to something different than 180 degrees, those would not be a possible answer choice. So that could be another test-taking strategy if you know the common sense of how many angles are in a triangle, but you're not sure how to get started on the example. Okay, so add like terms. 6x equals 180. Divide by 6, both sides. X equals, it'd be 30 degrees. So we know that this first one, that first angle, is 30, right? 1 times 30 is 30. The next angle is 2 x's, so 2 30s makes 60. And the next one is 3 x's. 3 times 30 is 90. So we're looking for 30, 60, 90. And we should end up with B. Okay, I'll leave 2 up here for a moment for you to try that on your own. And we'll work on that one together in just a minute. Okay, so how could we figure this out? Let me start with a fresh piece of paper so we can write on this. I'll duplicate what's happening here. Okay, so not quite to scale. The angles aren't perfect, but the measurements are there. We should be able to solve this no problem. So sometimes we have to follow more than one step to get to where we want to go. We know that because this is a straight line, that this angle and this angle are going to add up to 180. So we could do 180 minus 125 equals x. And over here on this side, 180 minus 125 equals y, if we call that angle y. Okay, so if we have that, it should be about 55 degrees. It's going to happen on both of these. And when that happens, now we know 2 of the 3 angles. So question mark is going to be, well, we have 55 plus 55 plus question mark adds up to 180. 110 plus question mark equals 180. Subtract 110 on both sides. And the unknown angle is going to be 70, or D. And notice I put in that 55 in there too, so that would be a trap if you're going too quickly, looking for the solution too early. It would be easy to put 55, but that was the intermediate step to find the answer. So be careful of that. The actual answer we're looking for was D, is the 70 degrees up top here. Okay, I'll leave number 3 up here for a moment. See if you can figure out the solution on your own. Okay, so here they give us a little bit of a story without a diagram. So oftentimes it helps to make a picture of this story. So a triangle. And it's named PQR. Angle P is 50. Angle Q is 60. So what is the measure of the exterior angle adjacent to angle R? So that sounds like what they're looking for is they're looking for not R, that's angle R, but they're looking for the exterior angle. Remember, an exterior angle is when you extend one of these lines, and they want to know what this is. So again, we can't go straight into finding X. We have to figure out what this angle is first. So let's find what angle QRP would be. And it's going to be 180 equals 50 plus 60 plus, we'll call it angle Y. Okay. So 180 take away 110 will give us 70. Oops, not 170, 70. So if 70 is Y, if Y is 70, now we're only one step away from finding X. So we do 180 minus 70 equals X. That's what we're looking for. So that's going to be 110 equals X. So the angle they're looking for is 110. C. Okay, I'll leave this solution up for just a minute. And we'll leave 4 there. See if you can figure out number 4. Okay, let's read number 4. So triangle FGH is similar to triangle JKL. F and J are corresponding angles. F and J are also supplementary angles. So which term best describes FGH and JKL? So let's start to pick this apart. Let's think through this a little bit. Maybe we can even draw a picture. So they're saying they're similar, so I'll try to draw something. Now, this is also can also be a trick on standardized tests, is the drawing that you see could look nothing like what they're talking about. I'm only drawing a triangle, and they look different. And I did that a little bit on purpose, because when we do this, FGH, we have to look at the data and the description more than just what we visualize sometimes. So if we know that these are not to scale, if we know that they are similar to each other, so it's saying that they are similar. So that means that if F and J are corresponding angles, and they're also supplementary. So that's where it gets can be a little bit confusing, because you say, well, if they're corresponding, that means they're the same, that F and J are the same measure, angle F equals angle J, if you're to measure those, not visually, but per the logic. And it asks, but they're also supplementary. So what scenario would that happen? If they're supplementary, then we're saying that F plus J equals 180. So what logic would work where if f and j are equal and they both add up to 180, then what is the measure? So what it says, it's asking which term best describes triangle FGH and JKL. So this is one where we have to think a little bit about it, because we have to figure out what that angle is before we can start to apply our definitions and understanding of what acute, equilateral, obtuse, or right triangles are. So let's figure out what F and J are. Since they are both the same, I can replace those actually with the same variable, right? If they're the same, then I could do something like this. Right? Because if they're the same measure, I could replace them with the same variable. Combining like terms, I'll have 2x equals 180. Divide by 2 on both sides, and x is 90. So if x is what we replace both f and j by, and x equals 90, then we say f equals j, and they both equal 90 degrees. Which makes sense, right? 90 plus 90 gives us 180. So let's go back to, so this is definitely not drawn to scale, right? Because if f and j are 90, well, that's a right angle. So a more accurate picture would be something like this, right? Where f is 90 degrees and j is 90 degrees, something like that. So we have to look at our definitions. So an acute triangle, that means all of the angles are less than 90 degrees. An obtuse triangle means that all of there is one angle that is more than 90 degrees. An acute triangle is also, or I'm sorry, equilateral triangle is also acute, but specifically that all three angles are equal to each other. So that would be like 60 plus 60 plus 60 would be 180 degrees, where all of the angles are 60 degrees. So a right triangle is where one of the angles is exactly 90 degrees. So that's exactly what we have today, is a right triangle. So the D would be the answer for that one. See if I can leave the solution up while we look at one more question. Be sure to post your questions if you have any on the topic we're doing today or another class you're taking. I'd be happy to help you with that as well. And we'll do one last example. All right, so a few more seconds to get that one out of the way and look at number 5 for just a little longer. Okay, so this one is asking us, which of the following is a possible set of measures for the exterior angles of a triangle? So again, what we're talking about here is if we had a triangle and we extended each of these lines like so. So these are the interior angles and these are the exterior angles. So here's what it's asking. It's asking if the exterior angles are 60, 120, and 180. Does this make sense? So it's asking which of these combinations, if any, are even possible to have. Now, if you did the supplement of 60, 180 minus 60, you'd have 120. And here that is possible. If you did 180 minus 120, this angle could be 60. okay? But now we're already in trouble because these two angles add up to 180 degrees, which would mean that this third angle would have to be 0 degrees, and that's simply not possible. So you can't have an angle less than that. You can't have an angle of 0 degrees on a triangle. And this is another part that doesn't make sense. So if this angle is 180, then that means there's 0 degrees left when you do 180 for the straight line that this makes. That's a straight line, 180 degrees minus 180 gives us 0. So that doesn't make sense. How about this one? Let's see if this one makes sense. So 75, 85, and 200. Okay. So right away we see a problem, right? Because if this angle, a flat line is 180 degrees. So if we did 180 degrees minus 200 degrees, what would we have left? We would have negative 20 degrees for that angle, right? 180 minus 200 gives us negative 20. So this one doesn't work. The first combination didn't work. This one doesn't work. Let's see if we can get the next one to work. Okay, so the next one has measures of 80, 125, and 155. So if we did 180 minus 155, that should leave 25 degrees left for that straight line. Makes sense so far. That's nothing wrong with that. 180 take away 80 would be 100 degrees. That's fine. That's okay. The difference of 180 and 125, so it'll be 55. Is that right? Now, if these three added up to 180, because remember the three angles of a triangle must add up to 180, then we would be in good shape. So does 25 plus 55 plus 100, does that question mark equal 180? 25 and 55 makes 80 plus 100, 180. So it checks out. So C works. What do we think about D? Let's try D just to see if there's multiple solutions. Okay, so if we have 120, 130, and 140, let's see what this might end up looking like. So the supplement of 120 to make 180 here, 180 minus 120, that leaves sorry, got to think about something else real quick. Okay, so that's 60 degrees left over here. The difference of 180 and 130 is 50 degrees. And 180 minus 40 gives us 180 minus 140 is 40 degrees. Okay, so now we have to check. So far, there's maybe nothing that seems too far out of place, but we have to make sure that 60 plus 50 plus 40, does this question mark equal 180? For it to be a legal triangle, it must add up to 180 degrees. So this, what does that give us? That gives us like 150. Does that equal 180? No. So this would not be a legal triangle. So the only one that would work, the only possibility would be option C. All right, I'll leave this up for 1 minute. that I think about wraps up what we wanted to cover today. Let me do one more check if there's extra questions. Go ahead and post them now. Be on for just one more minute to see if there's any more questions. Okay, thank you very much, everyone. I think that's a good review today of the material of exploring angles of triangles. And tomorrow, what are we doing tomorrow? Check that out. So tomorrow we'll do understanding the Pythagorean theorem. And let me know if you have any questions between now and tomorrow of the material we covered here. I can get those answered in the comments for you. All right. Thank you very much, everyone, and have a good evening.